the property was stolen. Okay? Regardless. This whole argument is ridiculous. I cannot believe that there are main members in the community that are siding with the perpetrators. It's ridiculous to me. But folks, whether you agree with me putting this out publicly or not, okay, we are supposedly a community of truth and truth seekers. Therefore, if someone steals from us and commits grand theft, it still ought to be put out publicly. I'm sorry. My loyalties is not to the community. My loyalty is to truth, folks, not to a community. Okay? My loyalty is to my Heavenly Father, my family, and truth. Okay? And this was not only wrong, it was way wrong. And now I've just showed that the police officer's report and findings were wrong. But folks, just so you know too, I am following up with the police station. I'm also going to be reporting the officer for not doing a proper investigation. I'm not going to go into all that. Okay? But just because the officer said it's a civil matter does not make it so. How many times have we seen courts reverse that stuff? So for some people to not put any weight into my testimony when I'm the one who actually had the property stolen.
I did not mean to play that. I'm going to get in so much trouble. That was for the court cases coming up. Hello everyone, welcome to the channel. How you doing? I am Craig, FTFE. We are here tonight to have a discussion / debate. Not really sure. We'll see how it goes. It's going to be about the Aether. You know, that thing that Michelson-Morley experiment disproved like over 100 years ago. We're discussing that tonight. We are discussing with Big Shoes, who is here in a nice looking shirt. A holiday shirt there, lovely. How are you doing, Big Shoes? Welcome to the channel. Oh, you're muted. You need to unmute yourself.
All right, I'm doing great. Thanks for having me on. I'm excited to talk with you.
No worries. Right, so I'm not really sure of your position, so why don't you just take a minute, introduce yourself, state your position about the Aether or gravity, whatever it is, and then we can get into have a discussion / debate. We'll see how it goes. I'm sure you've seen my channel and you're aware of my rule. The person I am speaking to decides the tone of the conversation. If you're decent, so am I. If you overtalk, act like a dick, then you get to meet my friend FTFE.
Too easy. I'm the same way, so I appreciate it. And so I'm Big Shoes. That's what I go by as a college nickname from back in the day. My general position here is that the abandonment of a physical medium to light in favor of abandonment of a physical medium to light in favor of literal empty space is probably the biggest mistake that we've made in modern history. And that I think the restoration of this concept in favor or in replacement of time dilation as an actual physical thing that occurs, and it being rather a measurement problem and a compensation for translation of coordinates, can make things make a lot more sense. So how you are anti flat Earth, I'm anti simulation theory. So I'm trying to make things make sense, and this is kind of what I've ended up at for my conclusion. So I'll pause for a second. If not, I'll kind of just get right in because the Michelson-Morley is going to be the first one that I know either of us bring up, right?
Yeah, that's where I always go for the Aether, because at least the concept of the luminiferous Aether, the medium via which light needed to propagate, was disproven with that experiment. So that's a good place for us to start.
Do you want me to?
But simulation theory, just quickly, simulation theory. I don't really like to have the conversation about simulation theory in general because, like God, is something you can't disprove. The way I see it, if we are in a simulation, then that simulation is of the Earth in space with gravity and everything as we experience and are able to measure and detect. So it doesn't matter if we're in a simulation or not, because even if we are in a simulation, the Earth's still a globe in space, etc.
I don't disagree. It's the same argument that was hundreds of years old, if not further, with Descartes and dream, right? Whether this is a dream or a reality. And for the record, I'm in favor of a round Earth, just to make sure we're on the same page here. But Michelson-Morley, so the Michelson-Morley test, in my opinion, didn't disprove anything other than a static ether. So the hypothesis that they were testing against was they were looking for a etheric drift that would have been equal to Earth's motion, Earth's absolute motion through this static or immovable ether. But even from like a starting point, a static or immovable ether through which everything is moving really doesn't make much sense. So
why not?
that paper, nothing is still and everything moving through it, right? Like if we look around, the air is not still and we're moving through it, right? The air moves with us as the Earth rotates. It flows on its own, right? Obviously not on its own.
But of course, the assumption back then was that, you know, the luminiferous ether was like the absolute rest frame. You know, that was the base that we could reference everything to. You know, the long and short of the MMX is that it birthed relativity and the understanding that nothing is absolute in the sense of speed, and motion and things like that. You know, everything is relative to everything else, which removed the need for any kind of medium within physics. It doesn't. There's no need for it to explain what we experience.
Well, so Einstein in 1905 called the ether superfluous, right? In his paper on special relativity. And when you say that it's not necessary, I think it is necessary to explain time dilation, because if time dilation can be explained as a fluid moving medium and the compensations that we're making through it, it makes a lot more sense rather than time being something that can be manipulated. My stance on time is that it's it's so cliche, but a human construct, right? It's a concept that we came up with to describe what is. Like same thing with dimensions. Like when we say there's, I saw something recently posted online. I was like, there's something confirmed in 37 dimensions. It's like, what does that even mean? And what is our definition for dimensions and how?
I get what you're saying. Yeah, we have a human concept of time, but time as an actual dimension within physics is a thing that has been shown for experimentation and our understanding of relativity. There's suggestions that space is actually a construct of time itself, but that's a very deep conversation. But time is something that has physicality that we can measure and detect differences in. Like when you're talking about time dilation, the way that it happens for us is that when something is moving relative to us at a massive speed, moving away to us or towards us at a massive speed, if we were to be able to measure the time passing on that thing that's moving away from us, it would measure different than if you were on that thing and measured the time. And that's just a consequence of things moving through space at speeds.
But these are, yes, these are all based on the assumption that light moves relative to each and every observer in the universe. And I think that that's a bad assumption. If we
it's not just an assumption, is it? That's something that can shown to be factual.
It hasn't. The biggest pieces of evidence, and we 100% get into these, is muon decay and probably the Halafe-Keating experiment where they flew the planes around the world. And those experimentations, I think there's alternate explanations for, and there's a lot of other evidence in favor of a light and etheric drift, including Dayton Miller's work in his 1933 paper, and then Einstein. Go back to 1905 with Einstein's paper on the electrodynamics of moving bodies. In that paper, he's very clear that this is at the time two things. He wasn't aware of Michelson-Morley, he claims, at the time he wrote that paper, and two. Is that in that paper, he's very clear that this is a coordinate translation and not a physical thing that happens. Minkowski comes up with space-time in 1907, 1908, and then Einstein reformulates or not reformulates, but frames general relativity within that space-time framework that Minkowski comes up with. But initially, Einstein is pushed back against the idea of space-time being the actual fabric or physical construct of the universe, and there's a quote from him. And
the main problem is that you're bringing up Dayton Miller, and everything Dayton Miller did was wrong. because he didn't do anything properly. And literally all of his work can just kind of be dismissed because it's not reproducible, and there were systematic errors. Miller's experiments weren't temperature controlled properly. His Aether drift turned out to correlate perfectly with temperature fluctuations that were going on at the time. He did his tests in open air, and temperature gradients in the room affected the refractive index of the air, messing with the light paths. The analysis was re-examined in 1955 by Robert Shankland. Him and his team reanalyzed Miller's data using better statistical tools and modern understanding. The verdict was, yeah, no, it's just noise, literally just noise and temperature variations. He did nothing to disprove relativity, and everything that he actually did was extremely sloppy work that wouldn't have be able to reproduce unless you were in the exact same conditions and temperature and everything that he was. He didn't control for anything. He didn't do science properly. Whenever anyone brings up Data Miller, they forget the fact that he wasn't very good at what he did.
I would disagree.
Why?
And
though? Why? Just saying I would disagree doesn't... I've just given you a list of things he did wrong. Why do you disagree with those? Why do you disagree that he didn't control for temperature variations? Why do you disagree that he did it in open air instead of a vacuum? Why do you disagree that he didn't do science properly? Just to say, well, I would disagree, it isn't a rebuttal. It's nuh-uh, and I don't like nuh-uh. I like to have an answer as to why you disagree.
He didn't compensate for temperature, and he said that he did make compensations for temperature. The 1955 Shanklin analysis was reviewed in 2001 by Dr. James DeMayo, and found that the Shanklin analysis was cherry-picking data and confirmation bias.
I read the analysis of that guy's paper, and it was like, no, they didn't cherry pick data. They ignored extreme outliers, which is the case in scientific analysis. Extreme outliers are generally problems with equipment and stuff, but actually analyzing the data itself within the variables that they would have put in place, it was just noise. That person that tried to say that their work was wrong was someone that just really wanted the Aether to exist. There was no temperature control. He didn't do anything to control temperature. He just did it in an open room, in open air, with no corrections for any refractive properties or anything that he was doing in his experiments. He assumed that the light he was using wouldn't refract because it was just over a small distance, but that's incorrect. He didn't do anything properly. You cannot use Dayton Miller's work as evidence of Aether when Dayton Miller didn't know how to do science.
He was an award. He won several awards, not for that paper, but for other papers that he was working on. He was respected at the time.
Yeah,
Einstein's quoted talking about Miller's work that if the Miller results are legitimate, that relativity.
If they are legitimate, but turns out they weren't. And as the PhD in the chat points out, to be fair to Miller, some of the modern statistical tools we now use hadn't even been created at the time when Miller did that work. If we analyze Miller's work with any of the modern tools that we use today, any of them, it literally just shows it to be noise, margin of error, with it, the equipment was actually able to detect, and just temperature fluctuations that correlate with what we would expect at that time. There was nothing at Dayton Miller's work that disproved or suggested that relativity wasn't correct and there was an Aether. Honestly, Dayton Miller, yes, he did some interesting papers, and he won certain awards for some of his ideas, but his work trying to bring the Aether to do the champion of the Aether and bring it back was so sloppy that it just literally can't be taken seriously.
Are you familiar with the Schnoll effect? I'm not very well versed in it, but what I understand about what Miller is claiming is that he found the magnitudes of the etheric drift to align with sidereal time. And that Schnoll, who was a Russian biologist, again, I'm not super familiar with his work, but what I understand is that he found biological changes that also were occurring with sidereal timing.
So I thought you would bring up Schnoll, and why it's not real science. There's zero peer review of any of his work. Schnoll's work was not peer reviewed, never reproduced, ever. and was published in journals more suited to aliens built the pyramids than legitimate physics. The radioactive decay is quantum-based. The decay of the isotopes is a quantum process, which means it's governed by probability, not direction or motion through some cosmic soup. Yeah, it was, again, someone just trying to reboot the Aether, but, you are going to scientists who, if you ask any serious scientist about the things that they have done, would go, well, they didn't know what they were doing. Why did Schnoll not get any of his work peer-reviewed? Why did he publish it in, slop journals rather than scientific journals? That's not something that we should take seriously.
I think you can make the same argument for a lot of modern work that has been proven to be true that hasn't. Let's take, Graham Hancock and some of his ancient stuff.
Sorry, what did you just say?
You can see.
Sorry, you cut out there. What did you say?
That's okay. I was saying I think the same argument could be made for many contemporary scientists that were considered fringe, and things often turned out to be true. Graham Hancock being a good example with his ancient apocalypse, and not necessarily saying that everything he is saying is correct, but he's demonstrated pretty visibility.
But okay, the difference between
pretty visibility, the difficulty of getting a fringe
the difference between being a fringe scientist and never getting your stuff peer reviewed aren't the same. Fringe scientists can put their stuff into real journals. No one's stopping them putting their stuff in real journals. But people like Schnoll choose to put their work in journals that no real scientist would take account for, and then go, haha, I'm published. All of these people that you're quoting are just desperate for the Aether to come back when it's literally not needed. Like you said, Einstein said it's superfluous. We don't need the Aether. The universe works fine without the Aether as something that is required. We understand time dilation and length contraction. We don't need Aether to explain them.
Well, let's reframe the twin paradox real fast in a way. Like, let's say you and I are twins occupying the same point, and 5 light years behind us, there's a flash of light, and just to make it easy, there's a single photon emitted from that flash of light. And at the instant that photon is emitted, we don't know that, but just by coincidence, I start walking away from you, and you're the twin that stays stationary, and I'm a twin that starts now having a velocity. Relativity says that light would reach that photon, that same one single photon would reach both of us at the same time, even though I've covered a considerable amount of distance since that photon was emitted relative to your position. Fair so far?
Yeah.
Okay. So relativity says that me moving away from you changed the time flow, changed the length, so that the time coordinate at which that photon would reach both of us is the exact same, instead of saying that it would hit you first and then me because I've moved away from you. Is that fair?
Yeah, it's a bit convoluted way of describing it, but yeah.
Well, I don't think, because the one-way speed of light has never been accurately measured. So
incorrect. It's been literally measured in the past 15 years about 2,000 times. We can use nanophotography to literally track
the one-directional speed of light.
You can literally track it with ultra high frame photography. It's been done several times. This is an argument, again, that is brought up by Aether bros that want it to be true. Oh, we've never measured the one-way speed of light. It's been done. It's been done a lot. You guys just hold on to arguments that were made 30 years ago as though they haven't been disproven.
What paper was measuring the one? Okay, how about then, instead of a stationary one-way speed of light, the speed of light for an observer that is moving relativistic to another observer, that has not been measured. That moving observer would actually experience that time differently, right? Because again, when saying that this photon,
the moving observer the moving observer doesn't experience it different. The moving observer would experience it the same. It's the person that's not moving that they were to measure the time on the person that was moving. They would measure a different thing than the person on the thing that's moving. The person that's moving doesn't measure time differently. They still measure time exactly the same.
Right, they would measure the same speed of light, right? So let me reframe it again, maybe a different example. So if you and I are sitting on a park bench together and we're measuring the speed of light from the sun that's coming towards us, right? It's coming towards us at C. I'm holding still, and you take off like Superman in a rocket ship going towards it at 75% C. If you measured that light that's coming at me that I'm measuring at C, you would also measure it at C. That doesn't make sense. That light, how would that light know to slow down or speed up?
It
or
doesn't. The
to
speed
be
of
able to
light
stay
is just
relative to
constant
you
in all
as an
frames.
observer?
This is just a law of the universe that the speed of light is constant
It's
in all
not.
frames.
It's an assumption. It's an assumption.
No, it's not an
and it doesn't
assumption.
make
It's something
any
that's
sense.
been measured and shown to be true. We know it's true because we use those things to, like, you know, I'm talking to you right now via satellite because I use shitty Starlink internet, right? And
Yeah.
Starlink have to use those transformations of, you know, the fact that we know there's a difference because it's moving faster so that we can communicate effectively. It's not just a theory
Agreed.
that's you know, we don't.
No,
You know,
I
it's
agree.
it's actually something that we do.
I agree with that, but it's a measurement problem, not an actual physical change that's occurring, is my position.
What do you mean it's a
The
measurement
key
problem?
to-
There's no problem with measuring. We're able to measure it, and we're able to measure it so accurately that we can transform it, which allows you and I to communicate effectively right now as though we're sitting in the same room, even though we're thousands of miles away, communicating with satellites hundreds of miles above us.
And how many satellites do I need to be able to locate an absolute position?
What?
I need 3 satellites to locate a GPS position, right? I need to trilateral it. I always.
I'm not talking about
trilaterally.
GPS. I'm talking about Starlink.
Right, satellite communication, and
Yeah, I don't need
communication
3
that's not
Starlink.
right.
I can communicate to you on 1 Starlink, but then that Starlink talks to the other Starlinks, which then
Right,
sends
but we're
it to a
talking
ground
about
station.
finding. But we're talking about calculating and measuring a position, right? A coordinate, right? The time being one of the coordinates in 3 spatial coordinates and 1 time coordinate in our 4-dimensional system, right?
Yeah.
Okay, so we need 3 if we're going to locate an absolute position. Well, it's the same thing if I wanted to use cell towers and find a position, right? If I'm only using 2 and I draw circles out knowing the time that it takes and the calculations that we're using, I'm going to have 2 overlapping mathematically viable solutions to that. And the 2 overlapping viable mathematic solutions to relativity are changes in frequency and changes in time. We measure time with frequency and frequency with time under the assumptions of the same speed of light relative to every single observer. It makes
It's not
sense
just
that,
an assumption. It's something that has been shown to be factual. Again, we know it's factual because we use that effectively. If the speed of light wasn't constant in all frames, then the way that you and I are communicating right now we wouldn't be able to do it. Like, you're trying to create problems where there's none needed. The fact is, like Einstein said, the Aether is superfluous. It's not needed. Everything makes sense without it.
Well, in 1905 it was superfluous. In 1915 he does say that we have to discard it as a concept altogether. In 1951 I think Dirac even says that in terms of quantum mechanics, that we should look to some type of rejuvenation of the ether. Not the same.
Yeah, but
movement
it doesn't
effort
matter.
ether,
It's
a
never
different
been
type
done
of-
and it's never been needed. Einstein never said there's the ether. He never went back on the fact that it's superfluous. He said it should be discarded because we do not need the ether. This is what you're not getting. We understand the universe without the need for an ether. We understand how relativity works without the need for an Aether. Why would we add something in that would just complicate it when it's been removed because it's literally not needed?
Reunite quantum mechanics and relativity. Let's go
Quantum
back
mechanics
to the
works
Michelson
fine
Morley.
without the Aether.
Let's go
Quantum
back
mechanics
to
is just
Michelson
about
Morley real
probabilities.
fast, if
You know,
don't
it
mind.
doesn't. We don't need the Aether to calculate probabilities using, you know, the what's the name of the equation? Sorry, the equation for probability.
Heisenberg
time,
uncertainty.
You know?
I'm with you.
Yeah.
Heisenberg uncertainty, right?
But you know, we don't need Aether for that.
Right.
It's just because
Well-
things that are moving at relativistic speeds, like electrons and that, they exist in a state of probabilities. So we can't say that they are in one position or another, like in standard physics, where we can say if we have a parabolic arc, we can figure out where it's going to be in space and time. It doesn't work like that with quantum physics. There's a probability of places that it can be. We don't need the Aether for that, and I don't know why you would say we do.
What are particles made of, right? They're excitations of a field, right? Like, what is that field? Is that field right now? That field is
I
literally.
mean, that's
empty
one way
space
of describing it.
Okay. Is there a different, more preferred method? Right? Because the way I've heard it is, if you ask 5 particle physicists what a particle is, you get 5 different answers. And not
Yeah.
listen, we know what they do. I'm not saying that we don't know what they do, or that we have our predictions and things of this wrong. But I think what particles are, I think it's all waves at the most fundamental level. I think that these are entrainments of ether at various levels, and that's where we
again, you're just shoving Aether
from.
into it when we don't need to.
Well, why are we pushing it out? If we go
because it's not needed. There's literally no need for it. Why would we put it back in when we don't need it?
To explain what particles really are and what it's made out of, like empty space.
You're trying to, yeah. You're trying to. Why? That's just something you're saying. It's an assumption. But vacuum theory says that it's not really empty space anyway. It's quantum. It's this virtual particles and stuff. But anyway,
agreed. What is a virtual particle?
To use the Aether to say that it's Aether when it's not. There may be something else that explains things, but you just want it to be the Aether. The Aether has been removed. Virtual particles aren't Aether. They're virtual particles. You don't need to call it Aether. It's a different thing. That's why it's called a different name.
Well, what is a virtual particle?
It's a particle that pops in and out of existence because of vacuum energy.
So it's a physical, actual thing that exists?
It's something that can be measured, but it's not Aether. It's a virtual particle. We don't need to call it Aether because we already have a name for it.
Would it be fair to say that it's a mathematical tool to represent energy movement within a vacuum?
No, it wouldn't be fair. Do you know what a Higgs field is? Yes.
I mean, roughly. I'm not an expert.
I mean, it's very simple. What we use a Higgs field for? Do you know what a Higgs field is used for?
For mass, correct?
What about mass? Do you know?
To assign mass? I'm not sure where you're going with this.
It's how particles get mass.
Okay.
Right. So again, why do we need Aether for a Higgs field to be there? You're just all you're trying to do is you're literally just trying to jam in Aether. Oh, there's something. Let's say that's Aether. No, it's something else. We've already got a name for it. We don't need
that was around for thousands of years and was discarded for again empty space, which we've shown that's not really empty, right? Like zero is again, I would say zero and infinity, both human concepts. But Michelson-Morley, they didn't measure zero drift. Right? They measured much less than anticipated.
Well, they measured within the margin. They measured within the margin of error of their machines. So what they measured is dismissed because their machine wasn't able to tell between nothing and that amount.
Did they make any recommendations as to how measurements might be improved in future experimentation?
I don't know if they made specific recommendations, but they have been improved. They have been improved. The accuracy of those experiments that are done nowadays are thousands of times more accurate with a much lower margin of error and still show that there's no Aether.
The conclusion of that paper says that they would likely get much better readings had they increased altitude relative to sea level and removed some of the shielding. That was an experiment that was done in their basement with relatively few turns.
But it's been done. It's been done. Again, it doesn't matter.
I think it's enough to restore plausible doubt.
Again, it's been done much more recently with much more accurate equipment. So we don't need to listen to what they said even back then when it's been done now with better equipment and Aether is still not found. Dude, all you're doing is you're trying to shove Aether in where it's not needed. Aether is removed. It's literally not necessary for the universe to exist. You just want Aether to be a thing. No, you can call virtual particles Aether if you want. You can say that there's no empty space, so it must be Aether. But that's just giving something else a different name. Aether doesn't exist. It's been removed from science because it's a concept that we were wrong about.
Well, it was removed from science under the assumption that from Michelson-Morley not having any, or Michelson-Morley results being low enough to be attributable to experimental error. Like, I don't discount that.
But again, it's been done nowadays with much better, accurate equipment, so that's relevant. All right, their results have been replicated with much higher accuracy.
in
The
which
Microsoft Morty
experiment?
experiments have been done multiple times, even in the past couple of years, with much higher accuracy equipment, and they get the same result. It's reproducible, right?
In what experiment, so that I can do some homework when we're done.
I don't have it to hand.
Done,
You'd have to just look up modern Microsoft Morty experiments, and you'll find a whole list of them. Okay. Microsoft Morty wasn't the only time that was done. It's literally been done hundreds of times with thousands of times more accurate equipment, getting the same results. Dude, I'm really, really sorry that you want Aether to exist, but it doesn't. There's no need for it to exist. We understand Lorentz transformation. We understand time dilation and length contraction. We understand virtual particles and quantum mechanics without the need for an Aether.
Before it was the Lorentz transformation, what was that equation was the not the Fizeau, with the drag, Fresnel drag. It's the same. It's mathematically it's the same thing as the Fresnel drag.
Not really, no. It's
no, mathematically
it's not quite the same. It's in different dimensions, so it doesn't really work out like that, no. But it doesn't. Again, it doesn't matter. Call the equation what you want. It doesn't matter. The equation works now.
Well, in the Fizeau experiment, they measured different speeds of light with and against a flowing medium, right? They used water and found that the speed of light was fast.
No, the speed of light doesn't actually change. This is another a misunderstanding of what happens when light goes through a denser medium. The speed of light doesn't actually change. C is still C and always will be C. But what's happening is light, which is an energetic wave, excites a particle, absorbs that energy, and then re-emits that energy, which is then absorbed by another particle, excites that particle, which re-emits that energy, and but that energy being transmitted, which is light, still always moves at C. But the absorption and the re-emission is happening, so it appears that light slows down, but it doesn't actually slow down. It's just
I understand that that's the explanation of what a photon is, but a photon, I would posit, is a mathematical representation of the work done.
Those are certainly words, but a photon is actually a thing. It's not just a mathematical representation.
So if it's a real physical thing, right? So again, if I'm standing still and you're moving away from me at relativistic speeds, that real actual thing that's traveling towards me at one speed is traveling towards you at the same speed from your perspective, but a different speed from my perspective.
C is constant in all frames. We've gone through this.
No, I understand, right? So if it's a real physical thing, right? If we just represent it, I know it's not the same as a baseball, but if we look at it like a baseball that's traveling towards us, I would measure a finite speed for it, correct? I would measure that speed at C. So we'll call it, for round, 300,000 meters per second, right? So that ball of light is traveling towards me at 300,000 meters per second, and you're traveling away from me at, we'll make up a number, 200,000 meters per second, 66%, right? So that one ball that's traveling towards me at 300,000 meters is traveling towards you also at 300,000 meters per second. And instead of it reaching me first and then reaching you second, it reaches us at the same time, but your time is different.
Yeah, you're saying it as though there's an issue. It's not. I'm going to quote the Feaster here. It's not a bug. It's a feature. It's how the universe works.
It's an assumption. And
no, it's not an assumption. It's something that's been tested. And you keep saying that it's an assumption, and I want you to stop doing that. Because if it was an assumption and wasn't right, you and I would not be talking right now. Okay? Our understanding of all of that is what is allowing you and I to speak.
Transformation
I was talking.
Relative to
I was in the middle of saying
relative to movement of the medium.
If you want to interrupt me, I'll get a little annoyed. But again, our understanding of all of this is what is allowing you and I to speak right now. If it was wrong, if it was just an assumption and not correct, then we wouldn't be able to do what you and I are doing right now. It's as simple as that.
No, sir. The mathematics, again, is like frequency equals time. Frequency equals 1 over time, right? So if your time's going to change and your frequency is going to change. Here, our base units for all 4 dimensions are all based on this speed of light, right? The meter is based on the speed of light. The second is based on the speed of light. So if we're going to allow our
Right.
base units to, yeah, go ahead.
I don't want to be mean here, buddy, but
Please.
I I don't think I don't think you had the base understanding of special relativity and everything, the way it actually works, and you've been a little bit brainwashed by the need for Aether to come back in. You're so entrenched in Aether being a thing. You were talking about with Graham Hancock, who's not even a scientist in any way, shape, or form. He's just a shitty journalist, and you're taking him as a scientific authority, and then you bring up Data Miller, whose experiments weren't done correct in any way, shape, or form. Do you not see what's happening here? You're so desperate for Aether to be a thing, for some reason, that you're going to all of the worst examples of science that there is. Everything that, if you scrutinize it even the slightest bit, falls apart. We do not need the Aether for the universe to function. It works just fine without Aether, and no matter how many times people try and shove Aether back into science, it's not going to happen because it's not needed.
Okay. What do you think happens inside of the singularity of a black hole where time stops? How does time stop from one perspective and have so if it stopped, it would have an infinite lifespan from one perspective, but it has a finite from ours.
Yeah, so let's look at the show Andromeda, where the last ship of the Commonwealth gets trapped in the event horizon of a black hole. And for them, no time passes at all. But then 300 years later, one of the ships that wants to sell that ship drags it out of the black hole. So even though just a couple of seconds passed for the ship, 300 years, or not even a couple of seconds, no time at all passed. 300 years passed outside of it until they pulled them back out of the event horizon. And that's to do with the gravitational compression of the black hole affecting space and time. But what I think happens inside a black hole is actually a bit different, because I'm starting to look at black hole cosmology as a possible alternative to Big Bang theory. So I think that possibly inside of the singularity of a black hole is an entirely new space-time that a new universe exists in. And that's possibly how universes are created. We are possibly inside of a black hole right now, which would explain the symmetry of the universe. That much more galaxies rotate in one direction than another, which would be explained by being inside a rotating black hole. Would also explain the apparent expansion of the universe as the singularity expands as it is created. And would also explain what would appear from the inside of the universe to be a Big Bang. So, hey, but that's just a thought.
All right. So a few seconds passing for that ship, excuse me, versus hundreds or thousands of years passing for another observer that then drags them out of it. Does that make logical sense to you?
For time dilation, yes. Of course it makes logical sense, because we know how gravity affects space and time. There's no it's not nothing not logical about it. It might seem unintuitive, but it's not logical. It's absolutely logical when you look at the physics of relativity. It makes complete and utter sense, and logical sense, and in fact it's one of the consequences that must happen if the universe works the way that we say it does. It's absolutely logical sense. The difference between something being unintuitive and not logical needs to be, actually looked into.
That's a fair. How would you how would you describe the difference between the two?
Well, unintuitive is something that just doesn't. It might not seem that it makes sense straight away. Like, if you look at from the perspective of a flat earther, right? It might be instantly unintuitive to understand how water can stick to a massive ball in space. That's not. Water doesn't stick to a ball. That's not an intuitive thing to think. But logically, it makes absolute sense, because we know that gravity creates a force that will make the water stick to the earth. So there's a difference between something being intuitive and something being logical.
So intuitively doesn't make sense, but logically makes sense. So I guess that would kind of seem like it doesn't make sense to you in your gut feeling, but it does when somebody else explains it to you.
But it does
Is that
when
fair?
no, not necessarily when someone explains it to you. It does when you understand things more, right? Like it might seem unintuitive until you then study the physics and understand that that's actually a consequence of why something happens.
Okay, that's fair.
Like, for instance, right? If I
Yeah.
was on the equator, firing a ballistic, missile north, right? The Coriolis effect, the Coriolis force, would make it drift ahead of the Earth's rotation, right? Which is a completely unintuitive thing. You think, what? Wait, hold on. It makes it go faster than the Earth's rotation. That instantly, most people go, no, that's wrong. It would go, the Earth would go underneath it. It would go the other way. Intuitively, the Coriolis effect and why it goes that way, it kind of feels wrong. But when you look at the physics of why it's happening and you understand the mechanism, it logically makes complete sense, right?
Okay. I think that a lot of it has to do with mistranslations and people using the same words and having different concepts behind them. So if I could ask you, or I'll provide if you prefer, what's your definition of real versus imaginary? And again, I don't want to put down, if you want me to give mine first, I have no problem.
Real versus imaginary.
Yes, sir.
I mean, real is real. Imaginary is what flat earthers think. When they imagine they've got a brain. Imaginary doesn't exist. It's the tooth fairy. I mean, it's not something we need to define.
Okay. Well, just for the conversation, just for the intent of this conversation, right? I'll offer mine. If you disagree, we can go from there. Which is exists independently and interacts physically. Is that fair?
Wait, which one's imaginary?
So real would be exists independently and interacts physically. And you could this isn't
okay.
like a gotcha. This is just for us to have a term.
If you say so, yeah.
Okay. So would you, based on that definition, would you call colors real?
Wavelengths of light are definitely real, yeah.
Perfect, right? So the color itself, I would call it, for this context, I would say that the color is imaginary. The color doesn't have an actual interaction. The wavelength would change, and red.
Well, the color is just a description of what's happening, right? Wavelengths of light are real. They're not imaginary. We don't imagine that there's a color. That is something our the receptors in our eye, receive that wavelength of light, and we perceive it as something that we have named a color. That doesn't mean colors are imaginary. Agreed. It's just we have named something that's happening.
Agreed.
Just so you know, in the chat, guys, one sec, there is a super chat goal, guys. I see Emma is the only one that's putting into it. So if you want to hit that super chat goal and help Emma. Sorry, carry on.
No worries. So just for the comparison here, so colors would fit the imaginary just in this conversation, right? I'm not saying it's...
Again, I would disagree that colors are imaginary. Colors aren't imaginary. It's just a name we have given to wavelengths of light. That's not imaginary. That's a name.
Okay, would not real be better then? Like real being exists?
No, I disagree. Colors are a real thing. Colors are an actual thing. Different wavelengths of light are colors. They are real things. Different wavelengths of light exist. That's not imaginary.
Different wavelengths exist. I'm agreed. The color is our own creation, right? Red is our own creation to identify that particular wavelength.
It's a name.
Right.
That's all it is. It's just a name.
Yeah. Okay.
It's not a creation. We didn't create red. We just named that perception of that wavelength of light.
Well, if you saw in a different, if your perception of light was different, or if you're colorblind or whatever, there's 1,000 different scenarios in which red to you might not mean red to me.
What?
That wavelength exists.
What do you mean red might mean red? The wavelength of light known as red, we will both know that that's red. Unless
one of us is
you're French, you call it rouge. It's still the wavelength of light.
If one of us is colorblind, that picture of what that wavelength is different than what the other person's internal picture of that wavelength is. Right? Is that fair?
I mean, they're still going to perceive something that they will be able to say, well, that's red. But being colorblind is not that's someone that's effectively someone that's broken. They're not working properly. That doesn't mean that what they're seeing is imaginary. That's like having an infrared sensor that isn't sensing infrared. It doesn't mean that that color has stopped being red. That just means that that person's particular sensor is broken. When a person's blind, the universe still exists and light still exists. They just can't sense it.
They're not sensing the same thing. It's I don't want to get stuck on that one, because where I was going to go with that next is length real, right? And again, based on the definition of exist independently. Same. Mine would say yes, and it's
length
dilated,
is real. Yes, length is 100% real.
Contracted. Well, if I measure the table and then I took away that table, it's a description, right? It's a description of what it is. Same thing as color. It's a description of something. It's not something in and of itself on its own. If I asked you to grab red, you would say red what, right? Like you couldn't just hand me red.
What, dude? What are you talking about? Like if something is a length, if it's a length, it's a length, right? That doesn't change because you're moving at a different speed. It's just our ability to measure it because it is moving at a speed. That doesn't mean the length has actually changed, right? What's actually happening is it appears that different length because of the way we are perceiving the light coming to us from it as it's moving away from us. The length and time haven't actually changed.
That's what relativity. No, that's what relativity does say. That the length actually does change. Like if you're
no. It doesn't say the length changes. Again, it just says that we would measure it different to the person on it, right? So, two things are happening.
No. I'm with you. Right. I'm with you. That's an important point.
So it doesn't say that the length actually changes. That doesn't what happened.
That we would measure time differently. We wouldn't experience time differently.
Yes.
You see what I'm agreeing with what you're saying, that's not an actual physical change that occurs. Like when you start moving faster, your physical reality does not change. But that is what relativity says.
No, it's not. You're getting it backwards. The people that are moving don't experience any difference, right? It's only the people that are watching them and then measure them would measure different to what they themselves would measure. Nothing has actually changed. Two people would measure the same. No, it's not. Listen, two people would measure the same thing differently. That's it, right?
I agree with that.
So it's not actually changing. Relativity doesn't say the length and time actually change. It's not what's happening, right? So imagine that you're sitting at a train station, right? And a train is going past you. It's the fastest train you've ever experienced, right? And beyond that train, there's two strikes of lightning. And they hit at the same time, right? So you're seeing the train go past you, and you're seeing those two strikes of lightning hit at the same time, right? Now picture yourself on that train, traveling as those two bits of lightning hit the ground. What is that person on the train going to experience?
I'm trying to get direction here, because if we've got two and we're moving this way, are we moving away from the train, moving away from the lightning?
Well, the lightning is hitting the ground beyond the train. So now the person's on the train, looking at that lightning hitting the ground, but they're moving along at the same time. What are they going to experience relative to the person just sitting at the train station, watching the train, and the two lightning strikes hit the ground in the distance at the same time?
I'm having trouble following on this example, but what I think we're trying to say the same thing in different language, because relativity says that time actually changes, right? And I'm saying it's a measurement. That's what you're saying. Right?
No, relativity doesn't say that time actually changes. That's what you're getting wrong. It doesn't say that time actually changes. It just says the measurements of it will be different, right? So the person on the train that's moving relative to the lightning strikes happening would experience the lightning strikes happening at different times because they're moving towards one and away from the other, right? So they see the one that they're moving towards first and the one that they're moving away from afterwards. So they are experiencing the lightning strikes happening at different times, but the person on the train station experiences them happening at the same time. So whose reality is correct? Is it the person on the train station or is it the person on the train? Because they're experiencing different things.
I'm having trouble with the two lightning strikes. That's what I'm not understanding here when we're doing
so
this.
just let's put yourself in the position of the person sitting on the train station, and in front of them there's a train going past, right? And in the distance, beyond the train, looking out in the distance, there's two lightning strikes that happen at the same time, just in the distance beyond you, right? So now you put yourself on the train, looking out the window at those lightning strikes, but you're moving. So the person on the train would experience the lightning strikes happen at different times because they're moving towards one and away from the other. But the person sitting on the train station would experience the lightning strikes happening at the same time. So there's two people watching the same thing, but they experience different things. Whose reality is correct?
Well, if they're just measuring different things, it's one single reality, and they've measured those differently, but there are absolute coordinates between that they can share.
But but who's correct? Is the person that watches them hit at the same time correct? Or is the person that watches them hit at different times correct? Who is right about what's happening? Because they are both experiencing different things. They're watching the same event, but they are literally experiencing
this is an accelerating
things.
Reference frame, though, because the angle of the light would be changing as we're moving. If we're moving perpendicular to it, this is an accelerating reference frame because the direction would be changing. We need to put it in a non-accelerating reference frame. So let's do a straight line example. That's what I was trying to say with
but this is my point, right? This is how relativity works, right? Both of them are experiencing the exact same event, but differently.
That's not how relativity works, sir. You're mistaken.
But it is. That's the point.
Relativity says that there is no simultaneity.
Relativity says there's no. Relativity says there's no absolute rest frame, right? But that's what I'm trying to say. These two people these two people are experiencing reality differently. So who is right?
But what you're saying is that there is a reality, and they're both experiencing it differently, but the same shared reality. Correct?
But who's right though? Is the person that says they hit at the same time right, or is the person that says that the one on the right hit first and the one on the left hit second? Which one of them is correct?
But I just want to make sure I'm understanding what you're saying correctly, which is that there is a shared reality, that there is an absolute frame that they are.
That's irrelevant. It doesn't matter. I'm just asking which one of them is correct.
Correct to what?
What's happening? Is the lightning hitting the ground at the same time?
They're both correct.
How can they both be correct? From this, how can the same thing happen differently?
It's not happening. I don't understand what you said. It's not happening differently. They're making measurements of the same thing that's happening within the same. But
they're measuring it different. They are experiencing the same thing differently, right? One person experiences One person experiences those lightning strikes hit at exactly the same time. Are they right with what they've experienced? If they went up to you and said those lightning bolts hit the ground at the same time, are they correct?
So are they
correct? If they say to you,
that lightning struck, we were at the same point. Me and the train, right? Me and the person moving relativistic. We were at the same point when the light struck. Is that correct?
Wait. You're moving ahead. The person that's sitting on the train station, that watched the train go past, and in the distance, the two lightning strikes hit the ground at the same time. They come to you and they say, those lightning strikes hit the ground at the same time. Are they correct?
When the lightning struck, we were at the same position, and then that person on the train kept moving. Correct? We're
just talking about the person sitting at the train station right now. They have come to you and they have said to you, those lightning strikes hit the ground at the same time. Are they correct?
If they see the lightning strikes hit at the same time, I don't see why they wouldn't be. Yeah.
Right.
I think they
so that one person has come to you and they've said that the lightning strikes hit the ground at the same time. You've said they're correct. Yeah. But the person on the train gets off the train, comes to you and says, well, I watched that lightning and the one on the right hit the ground first and the one on the left hit the ground afterwards. Is he correct?
That person moving towards one, or this is because what relativity says is that both those lightning strikes would keep the light coming from both of those strikes would have the same velocity relative to that moving observer at all times. So even if that observer is moving away from one light and towards another light, he would measure both of those lights at the same speed.
At the same speed, but not at the same time, because he's moving away from one of them.
No, at the same time as well. That's what time dilation is. The time would change that for
the
that
actual
person.
time that the lightning takes to get to the person on the train, because they are moving away from one, is going to be longer.
I agree with what you're saying.
This is literally how Einstein explained it to Maxwell, by the way. Right? This is how he literally
Maxwell who believed in the ether, right? And
yeah,
formulated
this is how he explained that it's not right, and this is how it was done. But again, which one of them is correct? Are both of them correct, or is just one of them correct? Because both of them have experienced the same thing.
They're both correct. But the way that you explained it is
so
not consistent with relativity.
That's the thing. That is what relativity says will happen. They will experience different things, even though it is the same thing, because of the speed they are traveling.
This is the problem, and this is what you just offered.
It's the Doppler effect, basically.
Because you offered three perspectives in this. You had two lightning strikes and an observer.
No, I've only offered two perspectives. I've only offered two perspectives. The perspective of the guy on the train station. I've offered two. Hold on! Please don't ever talk me. Don't ever talk to me. I've offered two perspectives, not three. One, the guy on the train station watching the train go past and seeing them hit at the same time. Two, the guy on the guy.
One person.
No, don't over talk me. Last warning.
You've been over talking me.
Last warning.
Please continue.
Right? One, the person on the train station is experiencing the train go past them and the lightning hit at the same time. That's one. Two, the person on the train experiencing the lightning hit at a different time. That's two, not three. Okay?
So you have... May I go now? So
you froze then. I did not hear a word that you said.
Okay, I'm sorry. Am I coming back now? I think the weather's starting to move through. We have two different scenarios, right? We have a scenario with a stationary observer, and we have a scenario with a moving observer. In the scenario with the stationary observer, I'm sorry.
Sorry, I was talking to the chat. I didn't mean Maxwell. I meant someone else.
So we have a stationary observer, and we have two lightning strikes. So we have 3 points in space. In the moving observer, it's the same thing. We have a moving observer, and we have relative movements at 3 points. Anytime special relativity is framed, it's movement between two observers and the light that's moving between them. Because I agree that the light emitted from a moving source, because that's most of the experiments that we have. And if there's some other ones that I'm missing, by all means, I would love to read into them, because I would love to be wrong on this.
Just literally go Google modern Michelson Morley experiments. You could have done that and not had this entire conversation.
I have. There's please, by all means, what gets listed is holophonic heating in 1971. There's some other tests of relativity.
There was literally stuff done in the past couple of years, dude. Just actually look into it. It's incredible how desperate you are to shove Aether back in when it's not needed.
In both of your examples, you framed 3 reference points. 3 reference points, and special relativity
I've not used the 3 reference points. I've used
in the both person. Scenarios, there was 3 reference points.
No, again, there's not. There's the person, one person watching the train go past and the lightning in the distance. Right, that's not 3 reference points. His reference point is just sitting there watching this happening. Right? You can ignore the train from the person sitting on the train station. That's irrelevant, right? The fact is, he is watching the lightning strike happen at the same time. So it's him watching the lightning strike. Now let's put a train there. And the person on the train watching the lightning strike. That's 2, not 3. For fuck's sake.
So if that lightning, those 2 lightning strikes for the moving observer, those 2 lightning strikes hit at the same time, right?
No, the moving one, they hit at different times.
They strike at the same time. They're observed at different. That's what we're saying, correct? They strike at the same.
Who said that's the thing? Do they strike at the same time?
I'm asking
you're trying to put an absolute reference frame here, this is the entire point I'm trying to get into you. There is no absolute reference frame. We don't need an Aether. This is why I keep saying to you, which one's correct? Which one's correct? They are both correct. Because there is no absolute reference frame. There is no Aether. There's no fucking need for it.
So if those lightning did strike at the same time, that observer, according to relativity, would see those lightning strikes at the same time, regardless of their movement, because the light would move to them.
Oh my god, what aren't you fucking getting?
I'm not sure what you're not getting. You're using 3 points of reference.
No, I'm not! Remove the train from the first example. Person watching lightning.
The train.
Right?
1 person, 2 strikes. Right?
Listen, just right. Alright, stop. You are getting very confused. Right? Let's remove the train from the first example and just have a person sitting down watching lightning. 2 lightning strikes hit the ground at the same time. Right? That's what they've experienced. Now, let's also imagine that there's a really fast train there and we put ourselves in the position of the person on the train and we watch the same lightning strikes. Do those lightning strikes hit the ground at the same time from the position of the person on the train traveling relative to them? What does relativity say? Relativity says no. Relativity says the person on the train will experience the lightning strikes happening at different times.
So those 2 lightning strikes were the same distance away from that moving observer when they struck?
He's moving towards one and away from the other.
Okay,
so for him, they did not strike at the same time. That's not what he saw.
That is according to relativity.
Relativity says the person on the train will experience them hitting at separate times. Why are we going round in fucking circles? Listen to me. You are wrong. Just fucking listen. I don't want to have to keep repeating myself. The person on the train that is going really fast will experience the lightning hit at different times according to relativity. Stop arguing with me. That is the fact.
You can yell as much as you like. That's not the fact.
Yes, don't tell me it's not right. That is correct. I've got PhDs in my chat telling me I am correct.
May I have an opportunity?
Are you going to say the same thing again? Because I will shout at you more. You are getting FTFE because you are being ignorant by repeating the same thing after I explain something to you. You need to understand you're not smart and I am. I am teaching you. Stop telling me I'm wrong when I'm telling you something basic about relativity.
Okay, so that lightning struck on...
Do you want me to get a PhD to come in and talk to you? Because you apparently me saying these words to you is not going in.
So the lightning struck equidistant away, right? It's going to be the same distance away in front and behind the person moving on a train track.
Yes.
Okay. So there's a finite, whatever that distance is, and then however fast the speed of light is moving towards that observer is how fast that, or how much time it's going to take to see that lightning strike, correct?
I've gone through this. Why are we doing it again?
Okay. So if that...
Why are we doing this again? I've gone through this.
Because the light is going to continue, the light in front of that observer is going to continue to move at the same speed as the light behind that observer. That observer is not...
Yes, and the person is moving away from it. So it has to catch up with them. Oh my god, right, I'm getting a PhD in to fucking... You are being so obtuse right now. I don't know how you're not getting this. Do I have to fucking hammer it into your brain? Right, let me bring a PhD in because, like, I don't know how many times I can explain the same thing to you. Jesus Christ. Like, maybe if you understood anything about relativity, you could have this conversation, but frankly, you are not qualified for this conversation. You're getting it so backwards, it's incredible. No wonder you think that Aether is real. You don't understand the most basic things about what you're trying to talk about. What's your level of education? Seriously, what is your level of education?
Does it matter?
Yes, it absolutely
Does
does.
it matter
What's your
for the
level of
idea?
education?
It
Do you
doesn't matter
have
for the
any
idea.
kind of physics
You're,
education?
yeah, you're not.
Do you have any kind of physics higher education, yes or no?
Say no. I'll just say no.
Right. Well, why are you having this conversation then? You don't know what you're talking about. You're not qualified for this conversation because you read some nonsense on YouTube.
No, sir, you're not giving me an opportunity here.
I've given you plenty of opportunities and we've gone around in circles about 20 times. Hello, Tony. I don't know how many times I can say the same thing. Help me here.
Okay. What's your guest's name?
He calls himself Big Shoes, but his name is Ed.
Okay. Ed, so let's rewind to the beginning. So
Yes, sir.
we have a person sitting there and they see two lightning bolts hit, and the light reaches them at the same time. For that observer, those events are simultaneous. Are we agreed?
Agreed.
Okay, from the point of view of one of the lightning bolts, it hits and then it sees the other lightning bolt hit. Do you agree with that?
I agree with that, but that is not how I believe special relativity is framed.
Can I ask what your basis for saying that is?
Could we do?
No, sir, you just asserted that you understand relativity better than I do. Please explain why you believe that.
If the lightning, so if we frame this on a line, and we put the moving
A line
observer
in time or a line in space?
line in space.
Okay.
So we have a line in space. The moving observer is in the middle of it. And
There
we
is no
have-
moving observer at this stage, sir.
We're doing the stationary observer. Or the
We're
moving train observer?
just doing stationary observers, sir. So we
Stationary.
started with the stationary observer between the two lightning strikes, and the light reaches that observer at the same time, right?
Yes, sir. We're agreed.
So for that observer, these events are simultaneous. But if the observer were a bit closer to one of the lightning strikes, the light from that lightning strike would reach them earlier, right? Than the
Agreed.
light from
Stationary.
Yeah.
Agreed. So stationary closer to one strike, correct? Yep.
Yes, stationary closer to one strike. So
Yes, sir.
whether or not the events are simultaneous depends on the location of the observer, right?
Whether or not the events are simultaneous. Yes, I would.
Depends on the location of the observer relative to the two events, right?
Well, whether they appear simultaneous or not, whether the light reaches them at the same time.
The whole point of relativity is that there's no difference between appearing, right? There is no absolute reference frame, as Craig has been trying to explain to you. So there is no difference. Yes, it appears that the light reaches the observer earlier from one of the events because the light does reach that observer earlier than the other event. So for that observer, those events are not simultaneous. Do we agree so far?
Yes, sir.
Okay. Now we consider a lightning strike, and we're going to have a. Let's. Would you like to stick with that example, or would you like to stick with an example that that perhaps is easier to understand?
Whichever you prefer.
Okay. Let's consider an observer in a plane. Okay, flying along, and there's a flashing bulb. He's standing in the middle of the plane. There's a flashing bulb directly above him. He sees the light hit the front and back of the plane at the same time, assuming that they're halfway down the plane. Okay, he's flying along. From his reference frame, the light spreads out, hits the front and back, and gets back to him at the same time. But to an observer on the ground looking at it, the light as the plane moves, the light traveling backwards apparently to him, hits the back of the plane first. The light traveling to the front of the plane hits the plane later. And this is because the distance from his reference frame that the light has to travel is shorter, because in the finite amount of time that the light takes to travel, the plane has moved. So that backward traveling light hits the back of the plane first, and appears to hit the front of the plane backwards, right?
Yes, sir.
So,
Yes, sir.
so both observers are observing the same system, and they're seeing different things, right? And
Agreed.
okay, so and there are different explanations depending on your reference frame as to what's going on. So we're now agreed that whether or not that there is no absolute time, there is no meaningful absolute time. Your time is dependent on your velocity, and whether or not two events are simultaneously also depends on your position.
May I interject?
Yes?
In our current understanding of special relativity says that if I understand correctly, says that the measured length contraction is an actual phenomenon and not an apparent or appearing to the other observer phenomenon. Because again, like, I agree with what you're saying. Special relativity in the paper, Einstein always talks that these are this is how things would appear, right? Appearing to the moving observer, appearing to the stationary observer, but not actual physical changes. And these that changes after that these become actual physical changes. The example that he gives in the paper is for a rigid sphere moving at relativistic speeds, right? And the sphere remains, at least again, my interpretation from the paper is that the sphere remains rigid no matter how fast it's going, even if it, I know we're saying that mass can't reach the speed of light, but it say, hypothetically did, that the changes in the length contraction would only be apparent to another observer. They wouldn't be physical, actual changes that occur. Is that fair?
No.
Okay.
And so perhaps a practical example would be useful here. So let's consider a muon, a high energy particle.
Could we stay on the? I don't mean to interrupt you, sir. Could we stay on the plane for?
Okay. So
Because
yeah, all right. Let's stay on the plane, and let's this requires.
If I could, the plane moving at relativistic speeds doesn't actually change the dimensions of the plane. It only changes the dimensions of the plane as they would be measured between different observers. Is that a fair assessment?
The distinction is that distinction is meaningless. So if one observer sees the plane as shorter, it's shorter for every metric that observer can apply. So that change in length is real. It's not just apparent to them. But the observer on the moving plane, doesn't see any change at all in the dimensions of the plane. They still see the plane as being fine. Now, the reason I wanted to leave this example is to go to a practical example of a very fast object entering Earth's atmosphere, being produced in Earth's atmosphere, muons. Now, these muons have a definite decay half-life.
Okay.
Sorry, is something happening off screen?
Yeah, I'm sorry. I have to just relocate out to the car, but I'm still with you, and just bear with me.
No problem.
Yeah, I'm doing a call. Sorry, we had bad weather today, so I was planning on taking the call outside and had to readjust.
That's okay. If you don't mind my asking, where broadly are you? Because the weather looks very nice.
I'm in New Jersey now. It's nice. We had some nasty. Thank you, sir. Thank you, sir. I was planning on sitting at a park. That's what I usually like to do, get some outside time after work. But we had some nasty weather roll through that wasn't going to allow that today. So I kind of coffee shop to sit in for a minute. But I'll hop in there.
Okay, now you're
hop in the
outside. It's
car.
all very cloudy, and I retract my statement.
Yes, sir. Yeah, so I'm aware of, but I don't think we've reached a resolution on the plane though, because I would agree that
but
these
I'd like
changes
to.
are apparent.
I'd like to stick with the muon example because it is very illustrative of the question that you're asking. So
Yes, sir.
So we've got a particle high in the atmosphere, and it should decay before it gets to the surface, because its velocity, even though it's fast, it's going to take too long to get to the surface, and it should decay. So
Yes, sir.
what does the particle see? The particle actually does make it to the bottom. Why does that happen? And that's because, from the particle's point of view, the atmosphere is moving really quickly, right? And therefore, there's a length contraction. The distance that it actually has to travel is not that large. What does the observer on the ground see? The observer on the ground sees that the length doesn't change. So how do they explain what happened? They explain that the fast-moving object, the muon, experienced time dilation, which is to say time passed much more slowly for the fast-moving object. Therefore, it didn't have time to decay before it hit the surface. So both observers see the same thing, which is to say that the particle makes it from high in the atmosphere down to the ground. But their explanation for what occurred is very different. The length contraction for the muon is very real. If that length had not contracted, that muon would not have reached the ground. It could not have reached the ground. From the point of view of the observer on the ground, the time dilation was very real. The time dilation that the particle experienced was very real, even though the particle didn't see anything. The particle didn't see anything change. So to say that the length contraction is only apparent is not true. The length contraction has very real physical consequences on the behavior of the system.
Are there other examples of this for particles other than the muon? Because I know when this was first measured, I mean, and this isn't evidence against it. It's just evidence to I just don't think we understand these things as well as we think we do. I mean, correct me if I'm wrong, muon G-2, and again, this isn't towards time dilation, I realize that, but muon G-2 has pretty much proven at this point the standard model incomplete. The latest results were kind of confusing me, to be honest with you, but I think that they agreed with the first two tests of the muon G-2 that were done, if I'm not mistaken, right?
You are mistaken. The latest results from the muon G-2 study suggest that there is absolutely nothing wrong with the standard model, and that its behavior is completely in accord. So it took them six. This is why I don't pay much attention to sort of these pop science stories that try and sensationalize this stuff. 6 years after the original announcement, it turns out that when you do the analysis properly and with due rigor, the result disappears.
Yeah.
So
there's a lot. Yeah, I apologize. The articles were very confusing on the explanation for that. So that's okay.
Can I answer your question? Can I answer your question?
Please.
Yes, there are other particles. In fact, so the Large Hadron Collider works by accelerating particles, atoms, subatomic particles up to relativistic speeds and colliding them. And so our understanding and processing of the data that comes from any of these large accelerators, the Large Hadron Collider is only the most recent and most spectacular. Well, it's not even the most recent, I don't think, but there are a bunch of particle accelerators around the world. They are all testing special relativity each time that there's an experiment. Additionally, sort of the special relativistic effects are incorporated into GPS satellites. So their clocks have to be corrected because of general relativistic and special relativistic effects. there is significant experimental evidence that our understanding of special relativity is correct, and general relativity. If you want to get into that topic.
Yeah, I would love to if we have the time. First, because I know when these experiments were first done with the Muon, it was the mesotron. I think it's who is it? Somebody in Rossi in, I think it was 1941 was one of the first papers published on the Muon decay or mesotron decay at the time. So if I'm not mistaken too, because the 2.2 microsecond lifetime that the Muon has at rest, the special relativistic effects of that increased the lifetime from our perspective to I want to say it's between 10 and 12 microseconds.
That sounds right, but I'd need to research these numbers because they're not at the top of my they're not at the tip of my tongue. But that sounds right. But
okay. And I find it peculiar, and this isn't hard evidence against. I just find it peculiar that we've measured the exact same decay rate as within the colliders under close to vacuum conditions. Because if I understand correctly, the relativistic decay was the same in vacuum at, again, between 10 and 12 microseconds as it was hypothesized for the in atmosphere decay, which, just for it to be the same in those two different conditions, both in the atmosphere and, okay, we're saying that it doesn't really interact with the molecules in the air, instead it goes, through the vacuum, and it still doesn't make sense to me that these are actual changes. I think that there must be a logical explanation other than time experience that can explain why we make these observations.
So I'd suggest that you need to be careful about that sort of argument. And the fact is that from a muon in the atmosphere is in a vacuum, right? It's if you look at it in terms of volume, I think something like 99.6% of the air you breathe is actually empty. It doesn't have any atoms or molecules in it. It's empty space, and so when you look at the 2.2 milliseconds, is that enough time for that muon to actually interact with the particle? And it isn't.
I'm sorry,
right?
Is it milli or microseconds? I think it's micro. I don't think, are they the same? And I could be mistaken.
Milli and micro are not the same. I thought, so I did just look this up. Sorry, you're right, it's microseconds. Microseconds are a factor of 1,000 smaller. So, that reduces the odds even further. So in effect, what we're saying is that basically a muon just doesn't have time to interact with a particle.
And if I'm not mistaken, the muon has no volume. It's a point-like particle.
I believe that's the reality is that I'm not a theoretical physicist, so I am slightly outside of my my regime here. But it doesn't. We're drifting a little away from the central point, right? Aren't we? Which is, you asked.
Well,
whether
I think it's important that if we're going to use muons as an example of relativistic effects and time dilation being an actual thing, that we understand what the muon is and how it interacts in other situations as well, right?
Can't I disagree with that violently? Because that would be true if the muon were the only example. But the muon isn't the only example, as we just demonstrated. So if the muon were the only example of time dilation ever occurring, I'd agree with you 100%. It's vital. It's clearly some character. It's clearly possible that some characteristic of the muon is important here. But given that it happens to other fundamental particles as well, we can conclude that time dilation is independent of the particle that's traveling. Is that not a fair conclusion?
And what other particles and what specific papers and or experiments? Are we just talking generally what CERN does, or are we talking a specific instance?
Well, there are dozens. There are textbooks on the applications of special relativity inside. In fact, I gave one to Craig. I believe I gave Craig an electronic version of a textbook about special relativity in particle colliders.
Okay,
Would you
because
like me?
I please, I would argue that particles are most likely waves, and intersecting waves create particles and entrain the
What?
medium. What's that? I'm sorry.
Sorry, no.
I didn't say
Um,
anything.
I didn't say-
okay. Let's back up a little bit, right? Because when we're talking about muon decay, again, 2.2 microseconds at rest, 10 to 12 microseconds at relativistic speeds. The muon being the heavier cousin to the electron. So it's like an electron with more mass, both being point-like particles of negative charge. The electron having a decay rate of, if I'm not mistaken, it's like 100,000 yada years. It's something a crazy huge number. It doesn't make sense to me intuitively that this heavier cousin would have such crazy differences in lifespan and not share more characteristics with each other.
Well, uh, sorry, you just made me laugh. Because intuition has nothing to do with either relativity or the standard model. Quantum physics and relativity are not based on intuition, and your preconceptions of what should happen need to be laid at the door, surely. Just because something disagrees with the way you think things should work. I don't understand the double slit experiment, right? I don't understand. It doesn't make intuitive sense to me. Does that mean I get to reject the experimental finding? Obviously not. It's observational data. So I just have to accept that my intuition is limited, and be guided by what the data tells me. The data tells us, and again, sort of, quantum physics is replete with more massive things being less stable. More massive nuclei, nuclei of very massive atoms have a tendency to be quite unstable, right? There are very few stable isotopes of lead or uranium.
What do you think is happening in the double slit? Do you have a hypothesis on what you think is happening?
I don't. I make it a point not to speculate. So there are multiple causal explanations. None of them have been validated. Some of them seem outright unscientific to me in that they can never be validated. The multiverse theorem, for instance, the hypothesis, is something I reject as just being completely unscientific and therefore not worth entertaining.
Agreed.
It'd be cool,
Yes, yeah, it would be cool. Bigfoot existing would be cool. The abominable snowman existing would be super cool. I'd be thrilled if the abominable snowman existed.
There's an infinite amount of universes, but in none of them can I dance.
Exactly. Well, the fact that stuff would be cool if it were true is actually a red flag for me. This is where I come to the conclusion, okay, that means you have to be super objective about it. If you think that such and such is cool, that's when you should be super objective about it. That's when you should step back and disconnect yourself from things, because there's clearly an emotive factor involved. And I would say the same about your skepticism, that you find something implausible. And I have to admit, I find stuff implausible about when I was learning the standard model, when I was learning relativity. And you have to step back. You have to compartmentalize that emotion, put it to the side, and just engage your rational mind and say, okay, what is the evidence here? What's the evidence telling us? What is the evidence they base this on? And it turns out that there's very robust evidence for special relativity. We use it quite often. Sorry,
right
that's
now.
that's a long screed.
No, so if we take that, going back again to the plane example, right, where we're saying that the length contraction that is being experienced is an actual physical thing, right? Like one of those dimensions is different compared to another perspective, that is an actual physical change that's occurring as opposed to an apparent change because of the times that it takes and the way that light is flowing back and forth, right? That's
Yeah.
fair?
Yes.
Okay. Okay, I would argue that we've only been able to make these tests against um, a medium that is not moving very much relative to our positions, and that if we can easily reframe special relativity as one of the observers being the medium, and that these changes are only apparent and that they're not actual physical. And then we have to, where we're going to diverge, and that's okay, is at the actual time dilation and whether that is what is occurring with muon decay and with particle decay and the halafic heating experiment and others, whether these are actual changes to time or apparent changes to time. And my argument is that they're apparent changes.
All right. So so we can do experiments where we get very precise atomic clocks and we move them, and we can
sir.
tell that the movement does change the readings on the clocks, right?
It does change the readings. Agreed. Yes, sir.
Yeah. Okay. And these things are not moving at relativistic speeds; they're moving at very modest speeds, right?
Agreed. Yeah, even
So-
just moving in altitude with gravity, you see the changes.
Yeah, that's exactly right. In fact,
Yeah.
over separations as small as 1 millimeter.
Well, how are we measuring that time, sir?
I beg your pardon?
I said, how are we measuring that time?
We're measuring that time using atomic clocks.
Right, we're counting 9 billion and change wavelengths of cesium
Yes.
to tick off a second, right? But if that light speed was to change, and we're using the same assumption that it's not changing,
What light speed?
So how do I reframe this? So if I'm in that satellite and I'm in the clock, because the emissions from exciting the electrons within that cesium atom, those radiative emissions are what we're using to measure the time that is ticking away, right? So if the light speed through that movement is changing and we're assuming that it's not, we would read different frequencies at the same assumed speed that we would
No,
at...
sir. No. The speed of light would not change the frequency with which the transitions are occurring. So all of those released photons could travel at half the speed of light. They would still be arriving at 9 billion per second, right? Because they're being so the speed of light is irrelevant to how many signals per second are arriving. What matters is how many signals per second you're getting, right? How many of these transitions? So we've got transitions. They're releasing photons. All that matters is how many of these are occurring. So it doesn't matter, as long as you're not in the first second of whatever, let's assume. Okay, let's look at it let's look at it in a macroscopic. Let's look at it in a macroscopic example.
Sure.
I'm in one building, and I send over one messenger every second to the other building. I just send a messenger across every well, let's send one messenger every minute. Okay. And at the other end, there are people and messengers start turning up every minute. Okay. Now I'm going to say to the messengers, now we're going to reset the experiment, and I'm going to say, okay, messengers, turn up, walk half as fast as you did last time. Okay. They're still going at the other thing. They're still going to show up every minute. Right, the time interval between those people showing up doesn't change. The amount of time they take to get from one building to the other does change, but the amount of time between them does not change. Do you see what I'm saying?
So you're sending more messengers now to make up
No, I'm
the
not.
difference?
I'm sending the same number of messengers. It takes them longer before. So, all right. Let's break it down. I'm in building A. Building B is 100 meters away. Okay. I send out a messenger. I send out all of my messengers are able to gauge their speed perfectly. They're going to travel at 100 meters a minute. Okay. And I'm going to send them out a minute apart. Okay. It takes the first one a minute to get across, and then the second one will arrive there a minute later, etc., etc. Now, so on and so forth. Now let's do the experiment again. Now I'm going to tell the messengers to work at 50 meters a minute. Okay, it's going to take the first one 2 minutes to get there, while they're halfway across, I've sent out my second messenger. I'm sending them a minute apart. So after 2 minutes, the first messenger arrives, and then a minute later, the second messenger arrives, and then a minute later, the third messenger arrives. So the speed with which the messengers travel does not change the intervals between the messages, right?
Speed at which because you've added, depending on your departure rate has increased in the second example. If I'm not mistaken.
No, it hasn't.
I'm trying to keep track.
Okay. So I'm sending them. I'm sending them out one a minute, and so when they get to the other end, they're still arriving at the rate of one a minute. Right?
Yeah. Okay.
They're all traveling at the same speed. So the speed at which they travel doesn't change the rate at which they arrive. So the speed of light has no impact on the frequency with which these signals are received.
It's unintuitive, isn't it? That's what I've been trying to say. It doesn't make sense in your brain immediately, but that doesn't mean it's wrong. Logically, it works when you understand the physics and mechanisms behind it. But unintuitively, I can see you, like, it hurts because it doesn't make sense immediately. But that doesn't mean it's wrong.
Yeah. And so, look, I've really enjoyed talking to you, Ed. But this is actually Craig's show, and I feel I've dominated.
Yeah.
I always appreciate you coming on.
Could I pose one example?
Yeah, sure.
Okay. So if I'm reframing the twin example or the twin paradox, if I'm with my twin at the same point in space, and a flash of light occurs behind me, we'll just make up numbers, five light years behind me, a flash of light occurs, and at that instant, my twin starts walking away from me at whatever speed we want, 2 miles an hour even, right?
Yep.
When that flash occurred, we were the same distance away from that light, and that light is going to continue to travel towards us at the same speed relative to each of us. So it's going to travel, it's going to close that distance going to the moving observer at 300,000 meters per second. It's going to close that distance to the stationary observer at 300,000 meters per second, correct?
Yes.
Okay, so in that example, who would the light reach first?
Well, it would reach the stationary person. The other so it's best to essentially all of these things boil down to distance. It's going to reach the stationary observer first. It's going to reach the moving observer later. Exactly how much later is actually requires some, 2 miles an hour or whatever it is. It doesn't really matter. But well, I guess it does over 5 years. But it's the amount. The thing is the distance traveled. So there's a distance. The stationary
If
observer.
I'm not mistaken, though,
sorry.
if I'm not mistaken, it's going to reach them at the same time,
No,
right?
you
And
are
the same
mistaken.
time coordinate, and the length
No,
is
you are.
going to.
No, you're mistaken. So it's traveling with the same speed, but it's traveling different distances for the two observers. So because it's traveling to different distances for the two observers, it'll take a different amount of time. Okay,
When
so
that,
so when
well, when
when
that's,
observer,
please.
when observer A receives the signal, it's traveled 5 light years. When observer B receives the signal, it's traveled 5 light years plus 2 miles per hour times 5 years plus a bit. Okay, so its distance is further. So even though they're traveling at the same speed, even though the light is traveling at the same, covering the distance in the same speed, it's traveled different distances to observer A and to observer B. So it takes a different amount of time to reach observer A and observer B. This is actually quite. Sorry.
No,
Go on.
So the stationary observer would measure that light once it reached me. It would measure that light moving towards me at 300,000 meters per rate, rounded 300,000 meters per second. And that moving observer that has a velocity that's greater than mine, whatever it is, would also that. So if I'm measuring that moving observer's velocity relative to mine, if we just make up some, we'll just go more extreme, right? If it's 50% the speed of light, that observer moving relative to me would still measure that speed of light catching up to them at 300,000 meters per second, even though it's catching up to me also at 300,000 meters per second. That doesn't make sense. I don't think that works. If it's an actual photon, right? If it's a single photon that's a real particle, right? That's trying to catch up to both of us, it would cover that. It would catch up.
So one of the earliest things that you will learn if you read a relativity textbook, and I kind of suggest that you need to, is how to sum velocities in relativity. And it's not the way we do it in Newtonian or Galilean. There's a different formula for adding velocities in terms of, and under that velocity, yes, it does make sense. It all works out. You have actually identified one of the things that Einstein had to resolve. Okay, Einstein had to resolve this problem. This is a problem, and it requires specific mathematical formulations in order to resolve it. But it is resolved in special relativity. Anyway, I do feel I've intruded way too much. Craig's been really quiet over there, and it's his goddamn show. So it's been a pleasure talking to you, Ed.
Likewise, thank you.
I always appreciate your expertise, Tony. You're always welcome on my channel, my friend. I very much enjoy listening to you talk.
All right, thank you. Bye.
All right, speak to you soon, mate. Bye. All right. Sorry I got a bit angry, right? But you just were not fucking listening to me.
That's okay. I'm having a good time. I appreciate it. That's nice talking to Tony.
Yeah, he's one of the smartest people that I've ever met in my life. And, I feel honored to be able to call him a friend. He's incredibly knowledgeable, and I like it when he tells me I'm wrong, because I know that I'm learning something. In the same way, and I don't want this to sound arrogant, I was trying to get you to understand that you had it backwards. You were wrong about it, and you just wouldn't accept that fact. And this is why I never became a teacher, because I would have thrown a chair at people.
Well,
So-
if I'm not mistaken, because when you and
thought we
I were
are.
speaking before we got on with Tony, we said that the measured changes to length were apparent changes and not actual physical changes. And if I'm not mistaken, again, Tony said that they were actual physical changes.
From the perception of the person that's measuring it. So, like he was explaining with the muon, right? The from the person's point of view, the muon is its time is changing. Time is running slower for it, so it doesn't have time to decay. But from the muon's point of view, it's moving so fast that the length of the atmosphere is moving so fast relative to it that its length is contracted. But both of them are experiencing different things. For the person measuring if you were looking at the muon from the person's point of view, it's a very real physical measurement that the person makes. But from the point of view of the muon, nothing has actually changed. So from one person, it would be real, but for the other person, it would not be, if you see what I mean. So it's very hard in this circumstance to say, well, it's an actual physical thing when it's not happening to both of them, if you get what I mean.
I do 100% get what you're saying, and that's kind of where my fundamental disagreement comes into place, because from the position of the muon, like it's 10 kilometers from where they're created to the ground, right? And I don't know the exact numbers. I'll make ballpark. So if I'm measuring it stationary on the ground, I measure 10 kilometers, right? But that muon, if it was going to measure, I agree that if it was using light as its measurement tool, it would measure less distance. But
Yeah.
from what we're saying with special relativity, is the actual distance in the muon's world is a shorter distance when compared to the stationary observer. That's an actual difference in reality. And I disagree. I think that there is a shared reality.
But then all you got to do is transform it, and from the person observing the muon, from their perspective, it's just the time that has changed for the muon, right? And that is to do with the interconnectedness of space and time, and it gets extremely deep as to why that happens. But yes, from the muon's point of view, absolutely, for them, the atmosphere would measure physically shorter distance than someone outside of the muon measuring the atmosphere. But in the same way, the person on the outside, the time that's traveling for the muon would measure different than if you were the muon measuring your own time. So which one's correct? Are they both right? Are they both wrong? And that's the fundamental basis of relativity. It is all relative. They're both correct. They are both experiencing what they are experiencing, because everything is relative to everything else.
I agree with everything you're saying, except those changes being actual physical changes, and rather those being apparent changes from those perspectives, using light as your tool to measure both time and distance. We use light as our tool to measure both time and distance. So if you did that, yeah, you would measure different. I couldn't agree more. You would measure differently. But I don't think that there's actually different realities for every single observer in every point of space. You could take every leaf on a tree as an observer, every eye in the world as an observer, and that light is moving different to
Right,
every
okay.
single. It just doesn't.
But here's the thing, right? A good way to think about it is that everyone does really create their own reality. For instance, wherever you are in the universe, you will measure yourself as the center of the universe, right? Everyone can't be in the center of the universe, but wherever you are, you will always measure yourself as the center of the universe, and that's because the universe is expanding away from you. An distant thing is happening. So no one is literally the center of the universe, but at the same time, everyone would always measure themselves at the center of the universe because it's all relative.
Completely agree. I think it's relative in measurement, but that there is an actual universe. There is an actual shared reality, that we do each have our own individual perceptions, but that there is a shared absolute reality around us.
So you basically say that there's like a bedrock. Yeah. You think that there's like a base reality that everything then works from, is what you're trying to say.
Yes. Yeah, I think that everything is. I think this is all real, and I think that there is a shared reality we each have our own perception of.
But that's the thing, right? a base reality is kind of what Aether posited, right? Is that was the base, that was the absolute reference frame for everything. But as unintuitive as it seems, that turned out to not be the case. And I know it doesn't make a lot of sense when you think about it first off. But we do all experience reality differently, but it's still the same reality. It's just the way the universe works.
But that's not what relativity says. Relativity says that it's different realities, right?
No. Relativity doesn't say it's different
movement.
realities. Relativity just says that it's relative. Everyone lives in the same reality, but what we experience is just relative to everything else around us that's moving relative to us. We can always consider ourselves as a lab frame, right? That's kind of a natural thing to do. You think as yourself as your base. I am the thing that is still in the center of the universe, and I measure everything else relative to me. But everyone else does the same thing. No one's wrong, but we're all living in the same reality.
Agree, but again, if we take it from the muon, that there's two different actual lengths rather than two different length measurements for the distance traveled by the muon, right? And I'm saying that they're different measurements of the distance, but that they're not actually, because if it is an actual distance, an actual difference in distance from the muon's perspective compared to another perspective, that's a different reality. If it's 2 kilometers to one thing and
but
10 kilometers to another thing,
you're saying that it's a different reality, but it's not. It's all the same reality, but it's all just bending and warping. It's like, imagine yourself being inside a bunch of taffy that's been chewed. It's all going to warp and move relative to you, and it's all going to look different, but we're all in the same reality, but the reality is warped by our experiences. And again, it's an unintuitive thing to think, but you just have to accept the fact that we're all in the same reality, but we experience it different. It's as simple as that.
Yeah, but that's I don't know. It's okay. We don't have to. I don't want to beat a dead horse. It's okay for us to disagree, because for the distance, the actual physical distance, for the actual physical distance to be different for two different observers, like that's a different reality. That's a relative reality, and I don't think that aligns
or
with
is it
reality.
a different reality, or is it just a personal experience of the same reality?
Well, that would be a measurement, right? If it's a measurement difference, then yes, it's a different experience because you're making different, you see different things, you're measuring different things. But if it's an actual physical difference, well, that's a different reality. I think.
Reality is just a way to say it, I guess. But I would disagree that it's different realities. In my brain, I just have to accept it as we experience the world, the universe that we live in, from our own point of view. And my point of view might be slightly different to yours because I'm not the same. I'm not moving the same. And it doesn't mean it's a different reality. It's just the feature of the universe. But that's just the way I see it. Anyway, it is getting towards 1 o'clock in the morning for me. And it is shoulders and back tomorrow, which I need sleep for. Because my back sucks. I can't even do a pull-up. I'm trying for 2 bloody years.
You ever try with the bands? Put them under your feet and do?
Yeah. I've been doing all the training for pull-ups, but I can get like 3/4 of the way up, but I just can't get that final bit. I'm working on my back. It's a nightmare. Anyway, thank you, Ed. I'm again sorry I shouted at you, but you fucking annoyed me when you just wouldn't listen.
I had a great time. It's okay. I appreciate you having me. Sincerely.
No worries. Right, so I'll speak to you another time. I'm going to end the call now. I'm going to say hello and stuff to my audience and then go to bed. So thanks very much, Ed, and I'll speak to you soon.
Thanks. Have a great night.
Bye. Oh, that was frustrating. Guys, thank you very much for the support. As always, the super chats are incredible. I really do appreciate it. This month, I was away the majority of the beginning of the month, and I haven't got around to doing a lot of stuff because I'm rebuilding my entire channel, making all the new graphics and everything from scratch, making the new episodes and everything. So I actually haven't got around to doing a lot on the channel, and genuinely haven't made a lot on the channel this month. So I thank you very much for the support that you give me. It means the absolute world. Emma for $2 says, hey yourself. Euros, sorry, she says. And then, will you do my push-up too? I'm married, Emma. Emma for €2 says, looks like I'm the only one. For €5, my favourite element is sodium. Why? Because na 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 Batman. Get out. Emma for €2 says, does anyone know some jokes? Chuck Norris built the hospital he was born in. Emma says for €2, extend time, I'm too slow. Hasking95, €2 says, Craig, play some RuneScape. Now, I'm addicted to Doom the Dark Ages at the moment. And then I want to start the altars. That looks great. Rachbot, $1 Australian, thank you very much. Hasking95, $2 Australian. Go full FTFE, he's boring. I did a little bit. Emma with another €2. And then I give up. I love you anyway, you cunt. Fuck you, Emma, you cunt. I love you too. How dare you give up. Hasking95, $2 Australian. I'm Craig, and I will delete Flat Clock app. I'd fucking love to delete that piece of shit. Emma, €5. Push-ups are lame. My super chat finger would be faster if you stripped again. Oh, I give them what they want. Hasking says, finish him. Rachbot, $1. Thank you very much. £5 from Slivery. The angle of the dangle depends upon the beat of the meat. Emma, €5. Oh, so sexy when you get angry. Full FTFE for the win. 31's been a member for 27 months. Says, I finished high school without a diploma, with no physics. Had to get my GED, and I'm so far past this guy in understanding relativity. I think my cat is, to be honest. Hasking95, who's been a member for 39 months, says, I need facepalm protection on desk for headbutts. Yeah, face desk protection coming next. Oh, I get this finished soon. I can't wait. Yeah. And then phase 2, we'll be getting the tune and Rubik's added. The tattoos look better now. My arms are chunky. NA gifted 5 memberships. Thank you, you awesome cunt, you. Earthly Skeptic, $1.99. Flerfs played dodge because Tony fucking got him. King Edward V, member for 10 months, says he does not understand speed is distance over time and like has to travel more distance to reach him, no matter the speed. I should have done it that simple, shouldn't I? King Ed V for $10 says, ask him this, if there are 2 cars going down the highway, one is going 60 and one is going 50, which measurement is right? The slower car is moving backwards to the faster car by 10 miles per hour or 50 miles. Again, he would have just said it's different realities. Emma, €2. If you take your shirt off, I'll take mine off. Well, here we are. It's getting there, right? Because then I was a fat cunt. Well, thank you very much, guys, for watching. I really appreciate your support. It means the absolute world to me. I'll be back tomorrow with a debate about is God evil. And then our normal Star Trek is 20 minutes later because I'm a dumbass and double booked myself. Next Saturday, I'll be debating a flat earther called Don. And we'll figure out some stuff for next week as well. And it looks like we're going to do another Infinite stream at the end of the month. NA $6.66 says, Craig, you're looking good, bud. Thank you very much. I'm working fucking hard. I was fat, but now I can do this. See you all tomorrow. Thanks very much. Remember, stupidity is not a right. Fight the flat earth.